Chris.
Hello.
David. What's up?
Hey guys.
I got a confession.
Oh God.
We were talking about some of the funny things before the podcast that we thought, like, as we were beginning Ruby development. At my very first RailsConf, I was still in college, and I was talking to this Russian guy, and he was showing me his Ruby code. My brain just started coming to like a halt, and I like kind of was like, I'm looking at this code, and I'm like, I look back at him, and I look back at the code, and that was the moment I realized that people don't write code in their native language. So I was expecting to see a bunch of like Cyrillic characters instead of like English def blah blah blah, and I was like, didn't know that.
I worked with a guy who was Italian, and a lot of the classes and method names and stuff were in Italian, but like I could sort of understand quite a bit of it because the Ruby portion of it was in English or whatever. And I could at least match the method names to the method calls. And it was kind of funny, but I was like, yeah, I guess I've never even considered that because all we do here is English. So yeah, that's fun. I wonder what the weirdest code bases are like that. Bet there's some crazy stuff.
But we've invoked his name several times, and we finally got him back on the podcast. Kevin Newton, welcome to the show.
How's it going?
Hey, good to have you.
Yeah, it is good to see you.
It's good to be back. It's been a while.
Yeah, I know.
I
We
was
need
gonna
to
say.
catch us up.
When was the last time you were on the show?
I don't know. It was a bit ago. We definitely talked after Prism got merged, but I don't know if we've talked since then. And yeah, I had a kid since then, and
Congrats.
And I left Shopify since then, and yeah, a lot of stuff.
It looks like March 18th, 2022. So almost 4 years.
Wow.
Jeez.
That's a long time ago.
I thought it was like last year. Oh my God.
Wow.
That's a long time.
Yeah.
Time flies. The Jason era. That was before EJE, before Jason exited.
We talked about syntax tree.
Yeah. Still going strong.
Yeah. Was Prism even a thing back then?
Yeah, but it was just beginning. I thought we had talked after Prism got merged, but I guess not.
Oh.
Yeah, wow.
I don't think so. No.
Wow, yeah, it was just beginning at that time. I think I was working on YJIT at the time.
Yeah, one of the notes here is Kevin works on YJIT at Shopify. Tells us how his experience has been since joining the team. The benefits of porting C to Rust.
Oh gosh,
So
yeah, we were in the middle of the Rust
yeah.
rewrite. That's right. Wow. Yeah,
So there's been a lot of changes since
So
then.
Prism didn't even exist then. Yeah, no, at that time I was working on YJIT, and I started learning a whole mess of stuff at that time. It was like a really good, God, it was like such a good team. It was such a fun time, honestly. Like that was like far and away my favorite team I ever worked on. It was great. People went their separate ways at a certain point, but I learned the most at that time. But yeah, at that point I hadn't even pitched Prism yet because I hadn't run into the problems that I needed to solve yet. But I was starting to get there with syntax tree. I needed a better parser.
So you had just joined the team at Shopify when we last recorded. So now you're somewhere else. You want to talk about what you're doing today before we get into the code and bits?
I left Shopify toward the end of, not last year, but previous year, whatever year it is. I've been at Meta now for about a year and a couple months. And I work on the Python runtime team, which is fairly similar to the Ruby and Rails team at Shopify, except working on Python. And yeah, trying to make Python faster for Meta and everyone else. And we work on open source projects that are trying to help the Python community. We've got a whole bunch of Python contributors on the team. So yeah, it feels at home. Still in a dynamic language, still working on JITs and stuff like that. But yeah, a little bit different.
I started in Python before I got into Ruby. So I'm curious to hear. I was very early, still in school, learning to code just in general. And like going from Python, where the language is kind of like there's one way to do things. And, you know, everything's pretty explicit. You have imports at the top of your files and your PyC files that it compiles bytecode and stuff. And then coming to Ruby, it was like, this controller doesn't have any requires or anything in this file. Like, how does Rails know any of this stuff? Where the hell does the params method come from? And yada, yada. I was very confused going from Python to Ruby. Then I read like metaprogramming Ruby. And I've heard people say stuff like rake in Ruby couldn't really exist the way that Python's designed. So I'm kind of curious to hear like your take going sort of the other direction, and with all of your experience at, this point where you've really deeply know the language itself, and now you're probably doing the same in Python land. So very curious to hear, what do you think about the two languages and their design choices and stuff?
Yeah, they're very similar and they're very different at the same time. Most of my work these days is in the actual runtime. So it's funny, at a surface level, I know Ruby very well because I worked in it for a long time before I dove down into the implementation of it in C Ruby. Python I did a bit of, but I have fully learned the runtime now and less learned the actual language, which is kind of funny. They make very different choices. It's interesting to see. It's funny you said imports are at the top of the file because, that's kind of a stylistic thing. You could have imports inside of method definitions. And effectively, that is what Rails is doing, right? With const missing and Zeitwork and all these other things. You could have requires at the top of the file. A lot of things
I was just thinking of the database adapters, you'll reference from a YAML file that you want SQLite, and then it'll load that file and it will call a method or something, and that doesn't require, instead of it just being at the top of the file,
right.
And it's dynamically imported that way. For the longest time, you're learning to code and you're just that's where they go. Well, this is what everybody does.
This is what you do. Yeah, totally. Yeah, Python has the same level of dynamism. It's just they have very different cultures around it. So it's interesting to see. Who knows? Maybe all of this is defunct when AI takes their jobs. But it is funny to see because you can accomplish very similar things in both languages, but the culture and style and all of this around it yields different results in both. But at the runtime level, there's some interesting differences too. When you're going down into the C code, Ruby's GC has these write barriers, and it's an incremental GC, and Python's is all ref counting. So a ton of the code that you see in the CPython code base is based on ref counts. You always see incrementing. And what I mean by that, you just use these random buzzwords. Ref counting is when you have an object that is holding a reference to another object, you increment this individual number on this object that says, on the second object, the child object, that says, someone is holding me. Someone is holding a reference to me. So don't GC me. Don't get rid of me. And then when you're done with that object, you decrement the ref count. And eventually, when the GC goes around all the objects and it says, okay, these all have 0 as a ref count, I can get rid of them. Whereas Ruby doesn't have ref counting. They have this other thing where it's a mark and sweep, but it has, the GC has been changed a billion times. But basically, when you have a parent object that is holding a reference to a child object, they are responsible for marking it in the GC mark phase, as opposed to just looking at a single integer. And there are trade-offs to both approaches, but it's interesting to see that one decision drastically impacts the structure of the code base. It's just everywhere. The other really interesting one is how errors are handled, exceptions are handled. In the C Ruby code base, there's something called set jump and long jump, which it's kind of like a go-to. It kind of just interrupts the flow of the code and just goes to a very specific location. Whereas CPython, in just about every single function call, if you return null, then it's expected that was an error. And so that also drastically impacts the structure of the code base. So getting used to those two conventions has been really interesting and weird.
Yeah, that sounds really different. How has it influenced your thinking about the way Ruby does it versus Python? Do you have
there's trade-offs on both. I appreciate both because they solve different problems. It's interesting. I really appreciate that I have gone to this team to learn this because my only experience with a large-scale programming language was Ruby. And so it's so easy to get into that, this is the right way to do things because it's the only way that you know. So now that I'm into the CPython code base, I'm like, oh, this is a completely different way of solving this problem. And I really don't think one is necessarily better than the other. It's just a different set of trade-offs that you're dealing with. And you have to mitigate the shortcomings of each approach in different ways. But more than anything else, I am obsessed with education, my own, selfishly, hoarding knowledge. And I love getting exposed to these various things. And maybe in a couple years, I'll go and do a different language entirely after this because I'm loving getting to experience all of these different trade-offs at the same time.
Are you tired of babysitting your job queues? Let us do it for you. JudoScale monitors and autoscales your job queues so you can stop babysitting and get back to coding. We support Sidekick, SolidQ, Good Job, and just about every other job backend in Rubyland. And of course, we autoscale your web services too. JudoScale scales up your apps faster than any other autoscaler, so requests, timeouts, and backed up job queues are mitigated before they become a problem. JudoScale has a free plan you can use forever, so there's literally no risk, whether you're on Heroku, AWS, Render, or any other cloud platform. Visit judoscale.com and get your job queues under control.
I mean, if you've used JavaScript and Ruby, you can tell there's so many different decisions along the way of how the language is designed and stuff. And you may not actually go down into the implementation of the languages like you have, but you can feel those things in your regular day-to-day work and whatnot. Because also I don't remember, the global interpreter lock stuff has always been a discussion for like basically ever, as far as I can tell, on both Ruby and Python. And didn't somebody, was it Meta or something, implement a Python version that doesn't have one? I can't remember.
It's called free-threaded Python, and my team is actually working on it, in addition to lots of other companies and people. But my team has people that are working on free-threaded Python full-time. Yeah, it's a really interesting effort. It's funny because this is one of those things that in the Ruby land, they've always said, this will never happen. This is impossible or too difficult. And on the other side of things, Ruby, Aaron Patterson implemented a compacting garbage collector, right? So values can move over time. I talked to some Python core members and I was like, would we ever consider implementing a compacting garbage collector? I was like, oh no, it's impossible. It would never happen. So it's so funny to see both language ecosystems be like, talk about impossible projects that could never possibly happen when they each are implementing the other person's impossible project. So it's just funny to see the cynicism of, oh, we could never possibly do this. And yet it is happening, just in a different language.
That's amazing. Is that something that is more possible because of those other decisions of like the way the garbage collector works or whatever? But
yes and no. I mean, at the end of the day, it kind of comes down to two things. One is the writing of the code and a migration path. Like the migration path is obviously very, very important. And the second part is like getting the word out and getting the ecosystem to change. So for instance, when you want to interface with the compacting garbage collector in Ruby, you have to opt in and say, hey, this value is movable. Here's a callback. Let me know when this moves. You would have to do something similar in Python. The people I was talking to were like, oh, but there's so many C extensions. Like it could never possibly happen. On the other hand, when you're talking about removing the global interpreter lock for Python, you have to go in and put locks on data structures everywhere. You have to go in and do this or implement lockless data structures or do like all these other kinds of synchronization mechanisms across threads. And all the people in Ruby core that I've talked to are like, that would be so much work. We're never going to do that. We're just going to go with Raptors instead. So it's interesting to see that kind of defeatism in practice.
That's really interesting. Yeah, because it's one of those things that the more you go down your implementation path, probably the more you feel locked into that approach.
Absolutely.
And I guess was what did you call it? The free threaded version of Python? Was that purely from scratch, like an implementation, or was it a fork of?
No. Yeah, they bolted it on. It's like a compile time option, and they have it is like an official version now. I think I don't remember what the first one is, but like 3.14 is one of the more recent Python versions, and you can do 3.14T, which is the free threaded version.
Okay,
and so there's like extra considerations you have to have when you're running that Python. You have to make sure that you are actually like locking things appropriately. But yeah, it's a different version of Python that's just compiled with different options.
Interesting. That's pretty awesome then. Because yeah, we've had Ruby Enterprise Edition and Truffle Ruby and like so many different like pure Ruby.
Thankfully, it's not an alternate implementation. I've been burned by that before. It's much better to not be an alternate implementation. Yeah,
I was going to say, it feels like an impossible challenge to keep up with because you've got all the new things like Raptors and whatever to keep up with, but you also have to maintain compatibility with C extensions or whatever. And like just the sheer amount of maintenance on that seems just giant. But
yeah, it's wild.
For anybody that doesn't know, do you want to give a quick explanation of the global interpreter lock just so they have a an understanding of that. We probably should have led with that, but
Sure. Well, your computer can run multiple things at once if you farm out work to different processors to make sure that they are reading the same memory and getting the correct writes and loads and such. You have to have some kind of synchronization mechanism. You have to have some kind of way of saying, hey, I am writing to this memory location. Please do not read an old value. So that's just kind of true of processors in general. In Ruby, to avoid having to lock every single data structure, to avoid having to put a lock on every time you have shared memory, imagine an instance variable on a class. That's basically going to be shared across your entire code base, right? It's not private to an individual object. In order to avoid having locks on all of those things, Ruby just says, hey, only one thread, only one processor can run Ruby at any given time. We're not going to let you run two Rubies at the same time. So there's a lot of code in C Ruby that can say, hey, I'm about to do something that's going to take a bit. Go and run a different Ruby thread. You can give up the GVL, or you can, there's also, other ways of doing this. I'm thinking about goodness, Falcon runs on fibers. Geez. There's other units of measurement that you can give, but at a certain point, it comes down to you're not allowed to run two Rubies at the same time, and therefore I have to have some kind of synchronization mechanism. And so the free-threaded version of that is I'm allowed to run two things at once, but it comes with, whole barrel monkeys.
yeah, that's fascinating. I feel like most Rails developers were just so used to, we get a request in and we process that, and we're not even spinning up threads to do anything, or we're just giving it to Sidekick to spin up a thread and manage, and we're like, so typically, at least, so isolated or insulated from that, I feel like as Rails developers for the most part.
It might change. I mean, if you ever have to get down into your web server's concurrency primitives, then you're going to have to deal with this. But going forward, I think John added some async queries to Active Record in a more recent version. You're going to start seeing that more. And I think one of the reasons Shopify is investing in Raptors, though obviously I don't work there anymore, so don't quote me entirely, but one of the reasons is they want to be able to, in a single controller action, be able to call out to other things concurrently and be able to process the result and then return it without having to run it sequentially because of GVL contention or whatever else.
Got it. Maybe we'll jump back over to Prism. Since we haven't talked about it since last time, what is Prism? It's part of Ruby core now. You're part of Ruby core now. What projects are using it? That sort of thing.
So all of this started because I wanted to write a formatter for Ruby. If you're going to write a formatter, you have to parse the source code into some kind of tree and then take that tree and format it out. And parsing the source code involves using a parser. There were three options when I set out to do this. One of them was Ripper, which is a standard library, which is kind of like a make your own, bring your own AST kind of library. Very difficult to understand. Absolutely no documentation. Still says it's alpha status in the documentation. Very hard to use. The other option was the parser gem, which was like the White Quark parser gem, which is used by Rupocop. And the third option was the Seattle RB Ruby parser gem, which was used by something like Brakeman or other tools like that. I didn't want to use a third party because I wanted to get this merged upstream. That never happened. That was way overly optimistic about it ever happening. So I used Ripper, and Ripper is incredibly difficult to use, and it doesn't provide all the necessary information. It gets very confused sometimes. Over the years, actually, because of Prism, it has gotten significantly better. But what I was noticing while I was on the Widget team at Shopify was that we had a team that was working on Truffle Ruby. We had a team that was working on C Ruby. I don't know if there was any JRuby investment, but there was also the Sorbet project, and there was people working on Rubocop rules. That's 5 parsers. Shopify was paying to maintain effectively 5 parsers, and the Sorbet team got bogged down working on pattern matching. The Truffle Ruby team got bogged down working on pattern matching. Everyone was falling behind. So I pitched. I'm like, hey, I would really like to bring a new parser because this was I was way over optimistic about my ability to deliver this quickly. And they're like, yeah, sure. If you work on it alone for a little bit. And then I had Gemma helping me, which was great, and Aaron helping me. And a lot of people contributed. Eileen as well. Really, the whole team at certain points touched it here and there. But after 2.5 years of work, we eventually delivered a standalone parser. So it had error recovery built in. So in the midst of syntax errors, it can still deliver you a syntax tree, which is important for the case of like an IDE. You need to be able to still have a syntax tree, even though there's errors in it, because most of the time that you're writing code, you have syntax errors because you're not done yet. So you need to be able to do that. It needed to be able to run on all of those different projects that I mentioned. They didn't want to just write a new parser for CRuby. They wanted to be able to write a parser for Rubocop and Truffle Ruby and JRuby and all these other projects, Sorbet, and it needed to be fast. So we wrote it by hand. We wrote a new parser, and it took many years of lobbying, but eventually they swapped over to using Prism as the default parser in Ruby 3.3, and it's been going ever since. So yeah, that's Prism. Once the AST was completed, the actual parser was completed, it also required rewriting the whole compiler. So there's also a duplicate compiler inside of CRuby now. So there's 2 compilers, which is super fun, but that exists as well. But now, to answer your question about which projects are using it, JRuby and Truffle Ruby both shipped with it. And Natalie, which is a third party, another Ruby implementation, also shipped with it. There's a new TypeScript one called Garnet, which is also using it. Rubocop switched over to it starting in Ruby 3.4. All of the Seattle RB projects have all switched over to Prism. There's a list on the README. And then Pico Ruby, I think, is switching over. So basically everyone, I think there were 11 active parsers in development last time I checked. When I first started the project, I think there are 3 now.
Wow.
Yeah, we consolidated. It's nice.
Honeybadger helps you fix errors, eliminate performance bottlenecks, and dig into the details faster than ever before. With support for Ruby, Elixir, and 8 other languages, it's the best way to gain real-time insights into your application's health and performance. Keep your apps fast and error-free at honeybadger.io. That's www.honeybadger.io.
Has it been cool to see other projects take advantage of it? Like I'm thinking specifically Herb, which everyone's been super excited about.
Yeah, it's been really cool to see people use it from other languages too. There's some projects going on at Stripe that are using it from the Rust bindings. And I think Herb is using it from the TypeScript bindings, if I remember correctly. No, that one's straight from the C library. But then there's like also other ones that are using it from the TypeScript bindings. It's awesome to see. I love seeing that. It's also been quite an education. I was like a moderate C programmer when I started. And like going back, it's actually like cringy, like looking at some of the stuff I've written because I have to go back and clean it up now that I've learned a lot more. But yeah, it's great to see people use these projects. I keep on getting notifications on Twitter of another project that's using Prism for some random reason. It's always fun to see.
Yeah, Herb's my favorite use case of it because it's like we've just been kind of, for the longest time, used to the ridiculous error page from Rails that's, you got a typo in this giant file. Good luck. There's something wrong in here. Now we have such a better way of finding like where the error is, which leads me to the question of like, I've always wondered that when you're parsing this, it makes sense when everything is correct, but what happens when there's an error? What do you do from there? Because it's like, eventually you could probably pick up at another point that is valid or whatever, but do you have to treat that error point and everything past it as invalid syntax, or how does that work? I was just curious.
It's a great question. It's actually an academic question. Like this has been studied in a lot of places. There's a lot of different ways to do it. There's a lot of approaches. No one approach has been considered like the correct approach. One of the things that you do in certain languages is you look for a synchronization point. It's funny, I'm using the word synchronization a lot. This is a different synchronization from the locking that I talked about earlier. But you look for a synchronization point. Like in C, you can look for a semicolon. Also in JavaScript, you can look for a semicolon. Well, actually, maybe not in JavaScript, but anyway. You can look for a point that says, this is definitely the end of a statement. I can pick up from here. Unfortunately, in Ruby, that completely does not exist. There's like absolutely no place you can do that because white space is very semantically significant in Ruby. Like people don't think it is, but it very much is. You can't just like look for a new line because those new lines could mean something different if you end the previous line on a plus or if you end the previous line on a dot. Like it's going to mean a very different thing. We've done a couple things. One thing that we do is we keep track of the context that we're in. So if you have like a class and you say class foo, and then you have a def, or you have like one plus or whatever, and if you find an end in the place where it shouldn't be, then we'll bubble all the way back up and say, actually, we're going to assume that this is closing the class. We're going to assume that you were like halfway through a statement and you just didn't finish your statement yet, and this end actually belongs to the class. So there's some kind of ambiguity here, because if you're inside of a class and inside of a def and you find an end, unfortunately, we use the same keyword for both of those ends. So it's like, is this closing the class? Is it closing the def? So I've had branches that I've worked on that then go and continue parsing, assuming both, and then look for the fewer number of syntax errors. Basically, you're into the wilds as soon as you find a syntax error, because you're just making a best guess. But your goal isn't like some kind of correctness. Your goal is like actionable feedback to the user. What is the best message I can give you? And one of the guiding lights has been like, Prism has always thought a bad error message is worse than no error message. I don't want to send you down a rabbit hole that is actually incorrect. So I've been trying to be as minimal as possible. But yeah, that is one of the things that we do, is like we keep track of the context. And if it would match like a parent context, then we'll try to close that out and assume that that's one chunk and then continue on. But yeah, it's interesting to think of every single file ever can be parsed by Ruby. It has actually happened one time accidentally. The guy who's behind Natalie accidentally parsed a binary file using Prism, and it gave him back a tree. Because that's what happens. That's what we do. We will always give you back a tree, just always with a list of error messages. So it's weird to think about, instead of raising a syntax error, we will always give you back something.
I mean, that makes sense. Like the bytes that you read out of a binary file, like it'd just be like reading any other file. It just has a whole lot of garbage in it instead of a significant amount of Ruby or whatever. That makes sense. Like there's no way for you to tell, you get to a specific thing and it's like, yeah, we're missing an end or two ends. So what do? We can't really tell you exactly where the issue is because it's so incomplete. We don't have enough information to give you. So that makes sense. But I really, really appreciate I'd rather give you a correct error message or whatever than something that sends you down the wrong path. Because it's a really good point. Like that is something that would save a whole lot of headaches. And I don't know how many times I've run into error messages that are not quite correct or whatever. And you like start poking through the source code and you're like, this ended up here raising this error, but that was not at all what caused the situation. So it's not helpful, but you had no way of knowing that until you poke around. So I like that a lot of like, just be very deliberate about raise more errors if you have to or whatever, because they can be very specific about this is exactly what's wrong rather than this is also the reason why you don't want to rescue like standard error in a lot of cases. Like,
you want to be specific. Yep.
Yeah.
Some classes of errors, I don't feel the need to put in a lot of effort to solve because, for example, you think about an unterminated string. I could go into a lot of effort to try to figure out where the termination point actually should be and where real code resumes. But if you think about the actual experience, everyone has syntax highlighting. If you have an unterminated string, you're going to see that. There's no need for me to put in a whole bunch of effort to find the termination point for you because it's all going to look like one string to you. So you can go and find it like very easily yourself. So thinking about like the user experience, it becomes much more like a product than you might otherwise think.
Speaking of syntax highlighting, do they also implement similar approaches there? Because they need to be able to analyze the text of the file and everything in order to estimate that, like, you opened a string here. Or can that be significantly simpler because it doesn't really have to understand the code as much as like a little bit more of the formatting?
It kind of depends. So kind of the standard for IDEs is to use a file. It's like a grammar file, but it's mostly just regex, which breaks my heart a little bit. Because there's plenty of places where it'll mess up. One of the things in the language server protocol is semantic tokens, which RubyLFP implements, which will go over your highlighting and go and add additional context. So as opposed to this is a local variable or a method, like RubyLSP will go in and say, okay, I actually know this is a local variable. I know this is a method call. So it can go and enhance the experience a little bit, which is really nice. Unfortunately, the standard is to use regex. So you can get into really weird syntax highlighting when you like use herodocs in weird ways. A lot of editors will like really mess up with herodocs because they're just very strange.
That makes sense. That explains probably a lot of the weird syntax highlighting I've seen over the years in my editor. You mentioned we don't know if it's a local variable or a method. That's one of the weird sort of Rubyisms that you don't get in most other languages. Like you have to declare the variable. And that was super strange to me. But at the end of the day, when you understand that, you're like, actually, this is really convenient. I don't have to worry about so much stuff, which is one of those things where Ruby kind of designed for the human being involved. But the trade-off is it's harder for the computer to understand that. And like, we've got to go do some more analysis to figure out, is this a variable? Did we declare that anywhere? Is it a method name that matches? Whatever. So
yeah, it's interesting. I mean, that's definitely optimized for writing. Like you can replace an adder reader with any other method and you don't have to change the call sites. That's great. It makes it a little bit more burdensome on the reader. So I think having good syntax highlighting like really helps that, which is really nice. Like go-to definition and all these other tools that like really make everything a little bit better. I think you have to have those tools in a more dynamic language like Ruby because that really rounds out the experience as opposed to relying on like the compiler to tell you.
And speaking of regex, you've got a new regex project, and we'll talk about your YAML parser too, but we'll dive into the regex first.
This started a long time ago, actually. I was still at Shopify when I got interested in doing this. There's a lot of different ways of creating regex, but there's a post by Russ Cox talking about, I think the title is something like regex can be fast and efficient or something like that. I'll send you a link, but it talks about implementing regular expressions using a specific kind of virtual machine, and it shows how to go about implementing that. And I was interested in this because around the time that I started implementing it was around the time a lot of people were talking about RDoS, which is regular expression denial of service, which is you have some kind of pathological case where you send something to a server, like a Rails server that is matching on regex, but the regex is like really badly constructed or something. And you find a way to make it so that it takes absolutely forever to match, which is why they started implementing a whole bunch of stuff in C Ruby. So they added timeouts to regex. There's like a global timeout. There's like an individual timeout. They added a cache to make it so that the states that you are going to when you transition within the state machine of the regex can have a cache so that they don't have to recalculate things. They added atomic groups so that you don't have to backtrack within those. So a whole bunch of effort was put in, but I really wanted to implement a new regex engine because I wanted it to be in pure Ruby. I wanted to be able to have that because Onigmo is like everywhere in the C Ruby code base, because not only does C Ruby use Onigmo for regex, it also uses it for all of its encoding support. So it's absolutely entrenched in C Ruby for all of the 90 encodings that Ruby supports. I wanted to go and rewrite the regex engine, but I also wanted to write it in a way that was not using backtracking. It was using something called like a Pike VM, which is, if I get real technical, but try to stay a little bit high level. When you're working through a regular expression, it's basically a state machine, and you can be in, one state at a time. And if your regex is only A, then you have a start state, and then it accepts A, and it goes to an end state. In this kind of Pike VM, you can be in multiple states at once. Every time you accept a character, you move into a different set of states. So there's no backtracking because it's linear with respect to the input string. That doesn't make any sense when you're listening to it, I realize now, but I hope that...
Neither does regex when you're reading it, so...
Yeah, it's okay. But anyway, all of that is to say, I really wanted to use this algorithm. I wanted to write it in Ruby because my goal is eventually I would like to write a JIT for it to JIT down to native for matching, because I think that could probably outperform Onigmo in most cases. So maybe one day, but it's going to take a while.
Yeah, that's pretty awesome to do it in pure Ruby as well, because we've seen, I don't remember what some of the libraries were, but there were a couple things that were removed and rewritten in pure Ruby.
Yeah.
If I remember right, because they were just like faster with the JIT.
Yeah.
With YJIT, which was kind of amazing to me, where it's like, wow, the JIT actually is good enough that the handwritten C code is actually less efficient than the JITted version of the Ruby implementation, which blew my mind when I heard that. Do you remember what those were? There were
a couple things. There was, for instance, array each was rewritten in Ruby, and it's used when YJIT is enabled, but not when RideJIT isn't enabled, or ZJIT for that matter. And there are a couple other tools that were rewritten in Ruby. I think there was one that was, I remember Aaron was working on like what's that Google? Oh, protobufs. They were working on like a protobuf implementation that was written in pure Ruby, and they were able to beat the C implementation. Yeah, so it's good. A JIT will always outperform. Like it has runtime information, so it's always going to outperform. You're just paying for it with memory. So that's really it. That's the game.
Which sounded like a good thing before the RAM prices went through the moon.
Yeah, right.
So maybe it's more expensive now, just in dollars.
Yeah. I mean, people they talk about how dynamic languages are slow, and that is the secret weapon of a dynamic language is a JIT. You kind of have to have that to compete. But when you do, and you have all that dynamic runtime information, you can make up the ground pretty easily. You just have to have more memory.
Yeah, it makes sense. Like you're just kind of delaying the work the compiler did ahead of time at runtime. It was effectively doing the same work, but it has knowledge. Maybe there's things that you can define a method dynamically and whatever. That becomes a bit trickier, different ways to deal with, but it's kind of the same work that the compiler is doing.
Yeah, I mean, to me, it's very similar to PGO, like profile guided optimization, which is if you're running in this is much less common in Ruby, but much more common in a compiled language like C. If you're running in production, you can run a profiler that will track a whole bunch of information about the types of things and which kind of fields are accessed when, cache lines, all kinds of stuff. Dump it out to a file, and then load that into your compiler the next time you're running it. And that'll lay out blocks slightly differently. It'll lay out, if you have a conditional, it will say, hey, I actually know that the else is much more common than the if in this case. And so it'll reorganize those. Those are similar efforts. It's all about taking runtime information and enhancing the development experience. But yeah, I mean.
Oh, that's super cool. Ever since I was in college, in computer science, I remember talking to my friends and we were because we had done C and we'd done Java and .NET, and then we got into Python and Ruby and scripting languages, and we were the coolest part of what will happen in the future is we will probably end up where you don't know what you're building yet. So you want to write it in a scripting language because you can be the most quick and efficient with it. But over time, you build a product and it kind of gets set in stone of how it works. And over time, that could just be rewritten to be compiled because it's we want to optimize for efficiency because change isn't as big of a deal in that over time. And we were talking about maybe there's going to be a way that you know what? The Rails code base, we're using version 8.1. That should just be compiled. It just works as it is, but our code on top of Rails can be dynamic and we can change it and whatever else or whatever. But Rails itself has these rules. When we call this method, we expect to have an active record object passed in or whatever it is.
Yeah.
There should be really a spectrum, which is I think where we're heading, with the JITs and everything. It feels like we're going from sort of a binary of it's either scripted or compiled. And now there's a lot in between, which is probably the hardest place to be there. But it feels like we're getting what we see with the JIT. It's faster to write the each method in Ruby instead of C. That's kind of mind blowing.
Well, it's funny. I mean, I feel like we're following a natural lifetime of a language like this. If you look at Java, everything's going to be faster if you write it in Java because calling out through JNI or whatever is a huge pain. But the JVM has so many layers of JITs. Depending on the JVM you're even using, they have so many layers. So they have an initial pass, which is, I think you can have it just purely interpreted and then go layer by layer by layer and keep going down. It's a sign of maturity at this point that Ruby is having these JITs. I mean, multi-tiered JITs are eventually going to be the next level if we get there, if there are companies interested in that kind of thing.
Wow. But, I don't think I even knew that was the thing.
Oh, yeah. I mean, the JVM is one of the most amazing, it's one of the modern marvels of the world. You look at it, it's absolutely incredible, very educational. It's fun going to other languages and learning these things. I'm really enjoying my experience with Python because I get to come back and look at Ruby and be hey, actually, this isn't impossible. We can solve these problems and see where else we can push it.
That's so cool. I was oh, Kevin's going to Python. We're going to lose him completely, but it's great to see that you're still doing this stuff. And
I was up late last night working on Prism, man. I ain't going anywhere.
I love it.
Let me just say thank you for that. By the way, from the community, thank you for your work on that because it's had a massive impact. So
yeah, no
we appreciate
problem,
you.
It's fun.
It really has.
Ruby's always going to feel like home to me.
Good. We'll keep it that way.
Sounds good.
You also had the crazy idea of like, let's build a YAML parser from scratch in pure Ruby. I sort of stumbled into that need a little while back. So with my Jumpstart app, we have a YAML file that, or used to, actually converted it to Ruby more recently. But what we used to have when we're reading your gem file, we would include specific gems depending on your configuration. So if you had Access Tenant enabled for multi-tenancy, we would add that gem to your gem file, but we just skip it otherwise. Because I think your gem file has like, there's a conditional like install if option, but it like always adds it to your gem file lock and it just doesn't download the gem, which seemed a little confusing. Yeah. So I went and just used a regular if statement in there because it's Ruby. But what happened was one of the Ruby versions or bundler or whatever, there was a little era where there were random version mismatches. Totally. I loaded YAML from Ruby, but the latest version of the YAML gem was point release further or something. And I didn't understand it at the time or whatever. And then I think Andre Arco was like, hey, I see you're dealing with the same thing here. Like in Bundler itself, we have a little very simple YAML parser because we can't load YAML ourselves because that'll pull the version built into Ruby, not necessarily the one that Bundler needs to require. And I was like, oh, shoot. Yeah, I'm getting real in the weeds here.
Yeah.
But as it turns out, I copied the one from Bundler, which is super simple, but it is not anywhere fully compliant like yours is.
Sure. Yeah.
So I'm real curious to hear about this because I was reading through the one in Bundler and was like, yeah, this isn't too bad. But it was like very simple, like parses arrays and strings and whatever else, you know, keys and values. There's a whole lot of complicated stuff you can do with YAML, and having the default labeled one and including that and other keys later on, like
anchors,
you see in your the anchors, that's what they call them. But you'll see that in your database YAML file and you just use it. But like that's one of those things that makes it more complicated to do because you got to pull the default, then like include this hash and another hash later on when we get to that point. And so I'm curious to hear about building. It's called what? Psych-Pure? Is that right?
Yeah. So that was named because Psych is the name of the YAML library in Ruby.
I want to ask about that too, because Psych, and then we require YAML, but YAML is Psych, and I've been a little. So and it may have just been stuff from before.
It is historical. So it used to be called SYCE, SYCE.
Oh, yeah.
Yeah.
I forgot about that. Yeah.
Yeah.
Okay.
And it used to be called SYCE. I couldn't tell you why. It was before my time. But I know Psych was written as a replacement. And at one point when you required YAML, it required SYCE. And now it requires Psych. I think Aaron was behind the Psych rewrite. I couldn't tell you who was behind SYCE.
Yeah, I'm pretty sure. Yeah, Aaron was the Psych maintainer.
But
to this day still.
Psych is a wrapper around libyaml, which is a C library. In the same way that like Nokogiri is a wrapper around libxml2. So, it's using a C library. The problem with libyaml, not really a problem, but like one of the downsides is that it parses comments appropriately, but it just discards them while it's parsing. So comments just go away. So when you go to get your AST from your parser, there's no comments to be found. Makes things difficult if you want to round trip your YAML, if you want to parse it, manipulate it, and dump it back out.
That would be exactly what I needed when we would update, because we have a little web interface where you can change the config in Jumpstart, and then we just wrote that YAML file back, but we blow away any comments you might have put in there or any like new lines or whatever. It's just gone.
Yeah.
Which I just kind of assumed it kind of makes sense that it's gone, but also like it would be really great to keep that stuff. So that was one of the things that caught my eye the most about Psych-Pure. It was like, oh, I just assumed this is a limitation of doing what you're doing, but being able to actually preserve that stuff if I assume you lose the comment if like the line around it or something changes. Like, how do you
It's
deal
a little
with
bit
those
weird.
things, I
Yeah.
wonder?
So it depends is the answer. But just to answer your original question of like why it was named Psych-Pure, there was a library inside of the JSON parser in Ruby that is Psych-Pure, which is just a pure Ruby parser of JSON. So that's why I added it, Psych-Pure. But to answer your question, so the way that it works, it parses out the tree and it parses out the comments in a separate list. And then it walks through the list of comments and attaches them to the tree where it feels is best. So if it's a comment like right before a line in an array, then it'll attach it to that node. If that node goes away, the comment will go away. If the value in the array is updated but stays in place, then the comment will likely stay in place. But I had experience doing this because I had written the Ruby formatter syntax tree. It is actually, when you dump it out, it is effectively a formatter, right? It's like, that is the same thing. So I actually ported it's the same algorithm that I use for syntax tree to attach the comments to the tree for YAML.
Okay, that makes sense. How long does that take you to build a project like that? I mean, you've had
it's
a little
interesting.
bit of experience.
Yeah, I've had a little experience. I know parsers really well at this point, specifically the kind of parser that I was building, a recursive descent parser. Like, I'm very comfortable in that. But fortunately, the YAML organization, which appears to be largely one dude on GitHub, has a tool written in CoffeeScript, of all things, that will generate a parser if you fill in this interface of like, how do you accept a single token? How do you accept one of many tokens? And so I filled in this whole interface, and then it generated a parser that immediately crashed. But it was far enough in that it basically wrote out the spec, and then I could find and fix a whole bunch of stuff. So it was less time than you would have thought because I was able to start from that skeleton. If I had had to start from scratch, it would have been a lot more painful.
Wow.
I had tried to start from scratch 5 years before this, and I couldn't hack it at the time.
Yeah, I was going to say, like, I don't even know where I would begin on something like that.
Yeah.
But that's really cool. So there's YAML reference parser is the name of it?
That's the one. He's generated parsers in TypeScript, JavaScript, which is funny to see, and also Perl. And
Perl.
Yeah. And actually, I think it's not TypeScript. I think it's just CoffeeScript. But it's interesting. There's a website that has a matrix of all of the various YAML parsers in existence and their conformance to the test suite. And libyaml does not pass all of the conformance. Like libyaml, the thing that Psych is wrapping, does not pass. Mostly because the YAML spec is insanely complicated. And libyaml was written for YAML 1.1 as opposed to 1.2, which is the most, 1.3 might be recent, but it's weird. I don't know if it exists or not. The only fully conformant parser is libfyaml, which also does give you comments, but does not have support for Windows, which is really unfortunate.
I wonder why that is.
Yeah, I couldn't tell you. But if you go in to that matrix and you look at it, one of my motivations was that there was not a Ruby library on there. And that was like embarrassing to me. Like I looked at that and I was like, no, from a Ruby core member, I don't like this. I don't like not seeing Ruby represented there. So I really wanted to have one there. But if you look at it, that like the list of parsers that are cross-platform, all platforms, and are fully conformant is really only the ones generated by this skeleton. So it only exists in JavaScript, CoffeeScript, Perl, and now Ruby. There you go.
Wow. Okay. I don't remember when I first learned of YAML as a thing. It also feels like one of those things that you kind of assume that this format of a file is designed for like easy for the computer to read and for the humans to read. But
You would
like
think.
YAML does not feel like that anymore. And maybe early versions of it were, but like these days it feels really complicated. You can glance at it and feel like, oh, this looks like a hash or whatever, most cases.
Yeah, kind of.
But yeah.
It's really unfortunate. I mean, it was originally designed to be a superset of JSON. So like all
really?
JSON is valid YAML, which is wild.
I didn't know that at all.
Yeah. You can just rename a JSON file to YAML and it'll just work. And that sucks. Like, I hate that so much. I had
no idea.
Yeah.
No. Yeah, that's wild because those are very different syntaxes from what you expect. I never use curly braces in my YAML files, but
Yep, that's called flow syntax in YAML as opposed to block syntax, and you can just can use it all day. Dude, I'm just waiting for the XML resurgence, man. I'm ready to go back to XML.
I was just
it's already on the come up. Like
I'm so ready.
Yeah. Just rename your .xml file to .yaml, and then you're good to go, right?
Yeah, I mean that's basically it. Yep,
that's wild. Yeah, I found that fascinating. Where it's like your expectations of like, surely this YAML format is convenient for both computers and humans to parse or whatever, and then you get into the weeds and you're like, wait a minute, this doesn't make any sense. What happened here? Because I don't know. I remember, was it Tom Preston Warner that made TOML?
Oh,
that format or whatever, and it was like,
that's what Rust uses. That's what Rust uses for like cargo and such.
I think Mies, the version manager, uses it too for their Mies.toml files and stuff, and it reminds me of the INI files or whatever, which Windows can parse those.
Heck yeah. Love me an INI file. Absolutely.
Yeah.
It's funny. I wrote a prettier plugin for INI many, many, many years ago, and I realized there is no spec. Like INI is no, there's no spec. There's the Windows spec, and then there's like all the other ones, because like Java used INI for a long time, like still does in a lot of places. You can just do whatever you want, man. It's the Wild West.
Just rename the INI file to .yaml and you're good to go.
It should be fine. Should be fine.
Jeez. As it turns out, all this stuff is a lot more complicated than you expect. And you just like, as a normal developer, you just use these formats and like grab some library, and you have no idea that like it's that complicated. I've seen over the years all of the security issues that are patched in Nokogiri or Psych or whatever. And it's like, well, I understand then that like parsing things is hard to do in general. And then like, when you have Psych being able to take a YAML file and then create a Ruby object out of it, because it's got a special, I assume that's a special syntax or whatever that Psych implements to be able to like, we're not just going to give you a hash. We can give you like a configuration object or something.
Yeah, I mean, in YAML, in the YAML spec, there's something called a tag, which you can put onto things. And this is like part of YAML. But Ruby uses that in order to tag it with the class. And then it goes and like constructs those objects. But yeah, constructing objects on the fly from configuration is just bad news, man. It's just not a good idea. Yep. Yeah. Which is why they have like permit lists now for the classes that you're actually allowed to load. They have like safe load YAML, which you're supposed to use, and all these other things.
And I believe load now is just an alias for safe load or something.
Yep.
So
there's also like unsafe load and like all these other things. Yeah. I mean, we've gotten more security minded over the years. It's good.
Yeah. Well, until these days where you just run, your AI bot locally with full root permissions and
dangerously skip.
No big deal.
Yeah, it's totally fine.
You guys have any other questions, or Kevin, you have anything else you want to chat about?
I was going to ask, what are you going to write a parser for next?
It's funny. I actually looked around a little bit ago. I love having like a nice side project to work on. But no, it seems like the community is pretty good. I was looking at Markdown the other day, and Cramdown is great. I don't see any problems with it. There's a pure Ruby TOML and other ones like.
You know what Cramdown doesn't do that I have almost built myself is like, I need a gem. I need a way to like get the front matter like separate from like the body, if that makes sense.
Oh,
like, there's no way to do that without regexing. Or you could do was it Duolingo that made that?
Psych-Pure.
Is it Duolingo that made that like CSV basically new format? The format that was for AI, but basically CSV. There you go.
Oh man, yeah. I don't know if I mean, one day I'll write a language when my kids are a little bit older and I have a little more time on my hands. That's my dream one day, but it's going to be a while. But yeah, I'm chilling on these side projects. Hopefully one day I'll be able to write a JIT for the regex engine. I think they'd be really fun, but it'll take a bit.
I mean, your definition of fun is some tough projects.
I like programming, man. It's a hobby and a job for me. So it's unfortunate when I need to like go outside and touch grass, but it's pretty fun.
Yeah, well, the kids can enforce that and make you do that. So
Yeah, I mean, right now when daycare is out, I'm off the keyboard. I'm not pulling it back up until they're asleep. My time is definitely pretty segmented.
I feel that. As soon as you have kids, then your time gets split pretty hard, partially.
Yeah.
There, which is good.
I found it
thing.
forced me to be a lot more intentional, which is good.
Yeah, now you're just rewriting everything in pure Ruby, and that's as far as you go now.
Yeah, that's as far as I go. I stopped there.
Love it. We'll have some links in the show notes to your blog posts about Prism and Exreg and Psych-Pure and stuff, so people can check that out. Any other place we should send people?
I'm still on X. I'm going down with the ship, and I'm on GitHub and my blog. So yeah, that's about it.
All right. I'll catch you guys next week.
Peace.